Hi, so welcome. I started this talk because I was at work the other day and we've been implementing some new stuff with an API. We got to an API endpoint and my coworker was making a post request to that API endpoint and it went across domains. And we got an error and he was like, I can't figure out what's wrong with this error. And I said, well, it's a CORS error. And he said, how can you tell? And I realized that he didn't know, and I have dealt with CORS on about 4 different applications now, and so I'm very familiar with all of the ins and outs of it, and so I figured this would make a good talk. So first things first, the first thing to talk about is, what is CORS? So CORS is cross-origin resource sharing. This is when you are going across origins, right? So you start in one place and you're going to reach across to another domain, another port, whatever, and you need to be able to get data between these two. And it's specifically in browsers, and it is specifically with fetch and XML HTTP requests. So anytime that you make a request between 2 servers, these rules that I'm going to be talking about apply. This doesn't apply to images. Images have a different thing. It doesn't apply to like videos. It doesn't apply to frames. Frames has its own thing. This is specifically for AJAX requests, and it's specifically only in browsers. So first, we're going to talk about the structure of an HTTP request and response, because if we don't talk about these things, you're going to be extremely confused if you have never actually looked at any of this stuff. So this is a simple HTTP request, and it's composed of several different parts, right? We have the request method. In this case, it is GET. There are several different types of request method. You have GET, PUT, POST, PATCH, head, options, delete. And I think that there's a couple more that I can't think of off the top of my head, but you have different words and different actions that you can do here. So that's always the first word, is the thing that you're going to do. Next, we have the path, the thing that we want to get to. In a GET request, or in any request really, you would be able to specify your query parameters here. So if this is everything basically after the domain. So it'd be /index.html /index.php ? Query string equals thing, right? Like it's all of that stuff. The next part of an HTTP request is the protocol version. There are different versions of HTTP. You may have heard some people mentioning like HTTP 2 and HTTP 3 and 1.0 versus 1.1 and stuff like that. Typically, HTTP requests are going to start off with version 1.1. There are browsers now that can support 2. 2 works slightly differently than the 1 version. We're going to only be dealing with the 1 version here because I don't feel like going into the specifics of how 2 works. And then the next section, which is sort of the important section, is the headers section. So these are our request headers. Now, all of this that I've just shown you is text. You can connect with Telnet, which is an application that just opens up a port and allows you to type things in. You can use Telnet to connect to an unencrypted HTTP server. You could type this in and you would get a response, right? You would be able to, and the response may be like, that's not a well-formatted response, right? Like, but it would be, you would be able to do that. So when we're talking about HTTP, it's all text at a certain point. So once we make this request, we're going to get a response back. And this response goes in a slightly different order, but it's all generally the same information. We start off with our protocol version saying, hey, we're going to be using this version of the protocol to talk from here on out. It gives you the status response code. So 200 means everything went okay, and this is how everything expected. In fact, anything in the 200 range is typically a good response, right? It is acknowledging the thing that you did, and this is the correct response that you're expecting. The 300 range is going to be your redirects. The 400 range is your you've screwed something up error. And the 500 range is the server has screwed something up error. So that is why when you get like a 404, this is where it would be. It would be 404 not found, because it is the server just can't find the thing that you're looking for. After that is the message. So 200 is okay. 404, as I just said, is not found. You have 403, which is permission denied. 401, which is not authorized, right? Like there's a bunch of different errors. So like you have different messages, different stuff like that, and it just sort of gives you some context for what's happening. The next section that we have with an HTTP response is the headers, which looks very familiar. You have, and it's once again with the headers, it's all just, you have the key that is the name of the header, colon, space, and then the value of the header. And then there is a space followed by the body of the response. And the body of the response is where your HTML goes, or your JSON response, or your XML, or what have you, right? Like this is the content that typically as developers we actually deal with. So now that we sort of have an idea of how HTTP is formatted, hopefully that'll help in the upcoming sections. So what about CORS? So CORS is the error that you get when you go to request something from another server and it doesn't work. And you go, I don't know why this doesn't work. What am I doing wrong? It happens when you are making an AJAX request in the browser. It is not something, if you go and you use curl or wget or something on that same endpoint, it'll work just fine, because that's not the problem. The problem is the browser. The browser is actually blocking you from doing this because it is a security thing. All of the browser vendors got together and agreed and made it a standard that servers should be able to specify where connections are allowed from in the response, right? So rather than having to figure out where you're coming from and then just like disconnect you, they give you a response that is, this is the things that are allowed. These are the places that are allowed. And then the browsers actually block it. So the response may actually complete, but the browser will not display it. It's kind of weird. So there are two types of cross-origin resource sharing requests. There is a simple type and a complex type that requires a pre-flight request. So we're going to talk about the simple ones first. The simple ones do not require a pre-flight. Now, they still have to abide by the CORS headers, which we'll go over at the end of this, but they don't have to do an additional call to see if they are able to do the stuff. So what qualifies as a simple request? There's a few things here that you have to be able to do. First off, you can only do a get, a head, or a post request, right? And once again, this is all AJAX stuff. If you just ask for a page in a browser, it doesn't have to do with that. It's really just if you are doing it as an AJAX request. You can only do a get, a head, or a post. You only pass safe listed request headers. So accept language, content type, which we'll get to in a second, DPR, downlink, save data, viewport width and width. There's a couple of others like user agent and some other things that you don't have control over that don't count, right? Like the browser sends some extra information to the server. You don't have control over that. Those don't count. These are the ones that you actually have control over, and as a developer, and if you send anything outside of these, it is going to have to be a complex pre-flight request. So I mentioned that content type has some additional caveats to it. There are only 3 allowed content types, which are application, XWW form URL encoded, multi-part form data, and text plain. You will notice that application/JSON and application/XML and text/XML and text/JSON aren't there. So if you're using a library like Axios or jQuery, and it is sending a JSON request, you immediately do not qualify to be a simple request, period. So that is a very important thing to remember, right? If you are sending anything other than these 3 types of data, you don't qualify as a simple request. There's a couple of other things. You can't have event listeners registered on an upload object, and you can't have a readable stream object. Those are lesser use cases, and I kind of put these separately because you're probably not going, if you're going to be using those, you're probably already aware of other things going on, and that this whole talk probably isn't for you. So a simple CORS request has to match all of those things, right? It has to abide by all of those, and the server that you are requesting to has to allow you to still make that request by using the access control allow origin header. So the access control allow origin header says, hey, I'm going to only allow these servers, like these origins, to be able to talk to me. Now you can specify you can specify, an asterisk as a wildcard. Everything can talk to me. I think Express does that by default, maybe, because I was playing with it earlier and I was like, oh, that's already there. So I don't have a good example here. But this is something that the server has to specify. If the server does not provide this header, you will not be able to make a request, even if it's a simple request, because the browser will block you. The server may respond just fine. You will never see that response, though. So this is the key one that you need to be aware of. So access control allow origin. Now you can narrow it down to a specific server, specific port, and you have to do the fully qualified domain and protocol. So you have to do https://mydomain.com, right? And that is what will be allowed to be able to use it. This is the big one. This is the important one. This is the first one that you're going to run into. And if you don't set this one, nothing else matters because nothing else will work. So let's talk about complex ones and what the heck is a pre-flight request. So when you are making one of the not simple requests, the browser automatically does what is called a pre-flight request, where it goes to the endpoint, it goes to the server and endpoint that you are wanting to call, right? And it says, instead of doing a post or a get or a what have you, I'm going to actually do an options request. And in that options request, the server needs to send back a few headers that says, hey, here's what's allowed, here's where it's allowed from, and here are the things that you can be sending me while you are making this request. And then as long as that pre-flight request goes through and has the data that, conforms to the thing that you're trying to do, then the browser will go and make the actual request. So when you are doing cross-origin stuff, there is a lot of times where you have to be aware of this stuff, because every time that you make a request, you're actually making 2 requests, and that blocks up the number of network requests that you're making. It doesn't exist in a separate thing. Now, this is usually where people get really, really confused by it, because as I discovered the other day, in Chrome, the options pre-flight requests, when you are attempting to debug this in the network tab of your DevTools, the options requests show up under the other category and not under the XHR category. So typically the requests that you're making using Ajax and all this sort of stuff, you can look at and kind of dissect over in the XHR tab, but the options requests show up in the other tab. So your GET request may just be like, well, it just never happened, right? There's a listing for it. You never got a response. Well, why didn't I get a response? You have no idea. And that's because you need to go look in another section for it. This is actually one of the reasons why I like Firefox, is that Firefox does this correctly, and they put their options requests in the XHR tab. So when you do a GET request, it shows you options, then GET. You do a POST request, you do options, then POST. And you're able to see immediately, like, this options request failed, and that caused this one to fail, and there's no confusion. So I'll go over this really fast. When your browser will do a pre-flight request and do an options call, and it will send over its origin, and it has a couple of headers that it uses. So access control request method and access control request headers. So these are the things that are going to be causing it to be not a simple request, right? These are the things. And so it's specifying like, hey, I'm going to do something weird. Is it cool if I do this, right? And the server can just fail at that point and be like, no. But it typically sends back a response that has no content, it has no body, but it has these special headers. So these are the ones that are actually the thing that are doing the work. So access control allow origin, where you said, does it match your origin, right? Access control allow methods. Here are the methods that you can do. And access control allow headers, and whether or not those headers that you sent are valid. And then it does the actual main request. So that's how a pre-flight request works. So these are like scary terms, but they're not. You don't have to do anything. The browser is doing this all in the background. And I think that's another place where people get kind of confused about it, because they're like, so I have to send an options request manually first. No, browsers is doing this in the background. You don't have to do it. Cool. So let's talk about the headers that the server needs to specify, because this is the part of it that really kind of messes with you. So we have allow origin, expose headers, max age, allow credentials, allow methods, and allow headers. So access control allow origin. You can specify the origin that things are allowed from. Now, at my job, we have a thing that sits in front of a proxy, or like is a proxy and sits through and load balancer and whatnot. And they're doing some of this stuff where they're saying, hey, these are the only domains. If you're coming for this thing, this is the only domain that is allowed here, right? Nobody else is. But on the other hand, you could actually make your application do that. So based on the token, the authorization token that's being sent, you could say, oh, the domain that's allowed is different depending on the token. We've looked up the token, and this is actually what's allowed, which would let you have a token that can be used on one site, but not another. So this is the one that's going to be like, no, really, I don't want you being used from this website. The next one is access control expose headers. So when you do a cross-origin request, you can inspect the headers that come back after that request is completed. However, the server can say, no, you can't. You can't inspect any of those. In fact, the only one that you can inspect is this one, right? And so you're able to limit it. So if you don't want them to be able to inspect the authorization, or if you have like custom headers that you're sending back that you want them to be able to see, this is where you'd specify it and say, here are the additional headers that you're going to be able to look at. Access control max age. Now, I mentioned before, every single time that you do a CORS request, if it is a not simple one and you're having to do a pre-flight, you're actually doing 2 AJAX recalls. And browsers tend to have somewhere in the neighborhood of about 6 network connections that you're allowed to do from any one domain to another domain at the same time. So if you're requesting multiple endpoints simultaneously, and you're like, I can handle 6 network requests simultaneously, so I'm going to call 6 different endpoints at the same time, but they're going across origins. No, you're actually calling 12 different requests, because each one of those has an options request and a GET request, right? So suddenly you can only do 3 requests at a time. With this value, you are able to say, hey, if I'm making an options request to this endpoint, store the options request and just cache that value for the next X number of seconds, right? So every hour you need to make an options request, not every single time that you call it. And that lets us cut down on the number of options requests and pre-flight requests that we're needing to do. So you could probably even make this match like the length of your authorization token, right? If your authorization token expires after 5 minutes, then make it the same length as your authorization token. And then you're caching it as long as that token is good. So this will cut down on the number of network requests if you're doing server development and browser development, right? Because both of these kind of go hand in hand. The next one is access control allow credentials. This is the other place that really screws people up. This one is a Boolean. It's true, false. There's not, it's like if it's there and it's true, you're able to use credentials. You're able to use authorization. If it's not there, then the browser just goes and you're trying to send credentials of any sort, cookies, authorization token, what have you, then the browser's, if it's not there, the browser's just going to stop it. And this has to be exposed on both a pre-flight request and it has to be exposed on the actual request that you're making. And if either one of those don't have it and you are attempting to send any sort of credentials, you're screwed. Also, if you're doing CORS stuff and you're using cookies as your method of authorization, please stop. Just stop. You are going to hate yourself so much in like a month. Just stop now. Okay, sidebar. Good. Moving right along. We have access control allow methods. So this is on your options request. And this basically says, hey, you can use get and post. And then if you try to patch to it, it's going to go, nope. So if you only have certain methods available, this is a great way to just sort of be like, yeah, you're not going to be able to do that. And you never get that request. And you don't have to do error handling for it. You still have to do error handling for it. I'm kidding about that. You don't just randomly, blindly not expect somebody to be like, I'm going to send some random stuff to this. Because that's how bad people get in. Okay. The last, I don't know if this is the last one. I didn't count my slides. Access control allow headers. So this is the other one that you have to specify when you are attempting to do authorized, credentialed, whatever headers that you need to be able to like authenticate yourself. You actually do have to specify authentication, I believe. You also have to specify content type if it is not normal. So if you are sending a JSON payload, you need to specify content type as an allowed header. Anything that is non-standard, you need to specify as a header. So typically it's content type and authorization are the two that you're going to need. If you're using cookies as a form of authentication, 1, stop. 2, you'll probably need to specify them here. 3, stop. And that's all that I have. Any questions?
Non-serious question. When do you start your ASMR career?
Yeah, that was good. I was like, ooh, cookies.
Yeah, that was pretty good.
Yeah, no, but awesome talk. That's really useful.
Yeah, I'm hoping that, and honestly, I pulled most of this information. I wanted to have like more like fun drawings and stuff like that, but I started last night, so I pulled most of the information from that link there. If anybody is needing a more thorough and in-depth explanation of anything,
So I have one question. You said the max age
can be set to, in your example, it was, I think, 1 hour.
Yeah.
Path specific or domain specific?
I haven't played with it enough. I believe that it is path specific.
The reason I'm asking is because if I'm sending, a request for one path, like I want stuff from this account, which is in the path, I'm going to send one set of authorization headers. But if I'm sending another request to another path with another authorization header, then the options requests are going to be different, I suppose.
Yeah, and obviously, like the max age is something that is should be used with caution and appropriate, safeguards and whatnot. If you have different authorization for different paths, then it's probably not for you, or for the same path with a different authorization or whatever. The place where it would be good is if we have an auto update thing, right? At my job, we track vehicles for business, and the GPS trackers that we use in vehicles only send a ping once every minute. So there is no reason for us to update the page any faster than once a minute. So we're not going to open up a socket and then keep a open WebSocket and wait, for stuff to come piling in, whatever. We just do a request once every minute, right? That would be an ideal use case for max age. It is a call that will be happening repeatedly. And rather than every time that you make that call, you actually make 2 calls, just make it be 1 call, and then like once every 5 minutes, 10 minutes, 30 minutes, whatever, do the pre-flight again. Because all of this is not security, right? This is equivalent. This CORS is equivalent to validating your form with JavaScript in the browser. That's not security. That's it's making it harder for people to mess up, but it is not impossible to still get things through if you're really motivated. Because if you proxy around this, if you write your own little helper function that just proxies through to the thing, you can change the CORS headers to be whatever you want. You don't even need them. It'll all be the same domain, right? So CORS can be gotten around. So it's really more about blocking people from directly accessing your stuff. So cool. Any other questions?
Yeah, the thing that got me was when you said is in cases where it will still make the connection out of the server, but the browser won't do anything back with a response.
Yes.
Well, if that's what I'm trying to do, if I'm trying to attack an end user, it's having them make the connection to the server that interests me. I don't really care if they see the result.
Right.
So that's, yeah. So when you said that and you talked about that and you talked about security, I'm like, yeah, from an attacker's point of view, I don't care.
Right.
That's awesome.
Go ahead.
No, you go ahead.
There's a big debate that's been happening in various threads around the internet of, if you are making some kind of web framework and someone gets some error in some course thing where it's a 300, 400, whatever, should you still make a successful request and then just say it's an error, or should you throw an error? And I personally think you should throw an error, because otherwise it's kind of showing, kind of like what Red was just saying, there was a successful request, it just wasn't, properly fulfilled or whatever. And so a connection has existed now. Might not be successful, but it's partially there.
Yeah. Yeah, this is the equivalent of putting in a thing in your htaccess file to stop people hot linking your images, right? People will get those images one way or the other if they're really motivated to. So this is merely a way for you to cut down on how much that is happening.